This week on Maker Update, a top that won't stop, overmolding your 3D prints, a twerking bot, and a guide to finishing your projects, no matter what they are. Hello and welcome back to Maker Update, the show where all your junk is cool, even the stuff that hasn't made it into a project yet. I'm Tyler Weingartner, and I hope you're all doing great. We've got a fun show for you. Let's get started with the project of the week. Aaed Musa is trying to fight physics. No, really. You see, his favorite film is Inception, and he wants to engineer a top to recreate the final shot of the movie. A top spinning on a table, possibly indefinitely. This will not be a screen-accurate recreation, but rather, he wants to create a top that will spin as long as physically possible, and without being influenced by forces outside the top itself. He begins experimenting with reaction wheels, which is sensible since those are what keep orbital objects like the ISS spinning, or not spinning, depending on what's needed. The trouble with reaction wheels in this application is that when the motor stops accelerating and achieves a stable speed, it stops applying a force to the structure it's spinning in, which is a phenomenon called saturation. It meant that reaction wheels were a dead end for this project. His next idea came from reviewing the final scene of Inception, how the top had a slight wobble to its spin. He would next use an eccentric rotating mass to maintain the spinning momentum of the top. This is essentially the same thing as the vibration motor you can find in your phone, game controllers, and electric toothbrushes. And it's an ideal way to maintain the momentum of a spinning object if it's balanced correctly. There's a small microcontroller, ESC, battery, and brushless motor, all stored inside to keep things moving. After over 40 prototypes, he's found just the right balance. Or maybe it's better to say the right imbalance to keep a top spinning. Most of the prototypes are 3D printed, but the final version has both the eccentric mass and the outer shell made from machined aluminum. The 3D printed tips were subjected to friction wear, so they were replaced by silicon nitride ceramic ball bearings. At final test, his overengineered top was able to spin uninterrupted for just over 2 hours. That's when the battery in the top runs out and is no longer able to spin the eccentric mass. It's not quite long enough to last the entire runtime of the film, but it's awfully close, and a lot longer than any other top out there. It's a fun video and an impressive achievement. More projects. Similar to the self-balancing bot we featured last week, Dorian Todd has created this tiny 8-servo walking bot with a ton of personality named Sesame. This is based on a similar bot he saw a video of, but other than the visual design, the rest of the engineering is all his own. The personality comes in the form of this OLED screen on the front that displays a number of different expressions and animations rendered in ASCII text. There's a lot to appreciate here. The adorable expressions, the animation fidelity, even the remote control. When Sesame starts up, it will create a Wi-Fi network that you can connect to in order to access a web-based controller to allow you to cycle through various movements and animations. But the other great aspect to this project is the extensibility. Dorian has already created a number of cosmetic variations, but also this Pro version, with high-end motors and optional wheels. All the files are available on his GitHub if you want to build your own. A few months ago, we featured this DIY parts counter, created by Helmke. And now we're checking in on the latest version of it. Simpler, faster, and more compact. The unique function of this machine is this sliding elevator that gathers the fasteners from the input hopper and arranges them into a single row for counting before moving them into the output bin. This design worked well, but the parts left scratches on the clear plexiglass, which destroyed the accuracy of the machine over time. The new version trades this line sensor for a computer vision camera, and the clear panels are replaced with white, so scratches shouldn't be an issue anymore. There are also fiducial markers on the moving and stationary parts, which helps with homing. All of the internal components are wired and controlled via CAN bus, which dramatically simplifies the wiring. It's a great little machine that continues to impress. And from north of the border, we have their first project of the new year, a desktop-sized dumpster fire, as an expression of his opinion on the year 2025. The body of the dumpster is made from thin sheets of styrene and glued using CA glue. This leaves some ugly joints, but he manages to work them in as features. Dumpsters rarely have pretty-looking welds. I also really enjoyed this tip for creating dents by warming up sections with a heat gun and then knocking some damage into it. The flames are sculpted in clay, and then a mold is created from brush-on silicone, which is used to cast the fire and resin. It's a gorgeous project, and like so many craft modeling videos, this one is riddled with great tips throughout. Now for a few tips and tools from anonymous Kiwi. They have a guide on how to create overmolded 3D printed parts with urethane. Overmolding is the process where an already made part is then cast with a different material that allows them to mechanically interlock. In this case, a part is 3D printed in a way that leaves portions of the print as exposed infill. He then places the parts in a mold and injects them with liquid urethane. When the urethane is cured, he's left with a 3D printed part interlocked with a soft, grippy rubber, which can be useful for a huge range of applications. From Mirza Makes, we have a great video on creating your own LED diffusers using an unlikely material, silicone. He begins by mixing up a plain batch of clear silicone, and the results are already striking. He then experiments with adding titanium dioxide and baby powder in separate batches to mix in and see which one works better to diffuse the light. It seems like baby powder is the clear winner here. If you ever need to create an odd-shaped LED diffuser, remember this one. And from the ironically named channel Stuck at Prototype, he has some advice on how to get into the right mindset to finish your projects. All of them, even the one you abandoned years ago. The first thing to establish is a clear idea of what done looks like. Understand what you're trying to achieve before you feature creep yourself into exhaustion. He also has some helpful tips in helping you commit to achievable goals and how to define your own timetable and deadline for the project so you have a drive to finish it. It's great stuff. For this week's DigiKey Spotlight, the winter weather may not have you in the mood for ice cream, but that's not stopping the team at Tomorrowlab. After being tasked to create something using the NXP S32M2 motor controller, which is a single board solution for 3-phase motors, they came up with the idea for an ice cream maker that can leverage the current sensing on the board to detect when the ice cream is properly churned. They're making use of an off-the-shelf manual ice cream maker and adding the motor to the top via a planetary gearbox. The included software gives them real-time feedback on the current when the motor is under load. But the real fun comes in the form of a servo-controlled sprinkle distributor, which adds in your additive of choice at the perfect time to be distributed. It's a pretty sweet project. All right, and that is going to do it for this week's show. I hope you enjoyed it. A reminder, as always, you can get more info about every single one of these projects by following the links down in the description. While you're there, leave us a comment, give us a thumbs up, and hit subscribe so you won't miss the next one. Huge thanks, as always, to DigiKey for making this show possible and to you for watching. Take care. We'll see you soon.